He was the first scientist to become a public figure, a legend in our times. The realities of 20th century science, its power, are linked with Einstein's image.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is thought equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cockcroft and Walton in 1932 experimentally.
The world of experience and the narrowness of consciousness bring about a sort of atomizing of the life of every human being. In a man of my type, the mind disengages itself from the momentary and merely personal and turns toward the mental grasp of things. 1905. In Europe, there is peace and stability. Europeans are comfortable and secure in their well-ordered life, confident in their ideas and ideals. A sense of progress and power is part of the way of life. Previous generations have given them a revolution in coal, steel, steam power. Now there is a further revolution. Electricity is completing the transition from the medieval to the modern world. In the Swiss town of Bern, Einstein wrote that year the 3 papers which revolutionized thinking in the 20th century. He worked in a patent office, technical expert, 3rd class. His job was to analyze the gadgetry of the modern era, telegraphs, telephones, precision instruments. At night, he continued his studies of physics. An outsider, he began to reshape scientific thinking. Who was he? These are the photographs of his youth. A German Jew, comfortable if modest childhood in Ulm and Munich. He rebelled at an early age against the rigidity of the Prussian classroom. At 16, he sought a less coercive education in Switzerland. For a Jew in Germany, advancement in the professions was not assured. His goals were simple: to study at the Zurich Polytechnic and become a professor in the natural sciences. One should do things for which one has talent. Besides, there is a certain independence in the scientific professions. He failed at first attempt, the entrance examination. Something of a vagabond, independent, Einstein thrived in the only European democracy. He developed a passion for nature and experience, flights of imagination. The young Einstein was still not a distinguished student. Rather, he preferred experiment on his own, talk in cafes, and the books of the new physics, especially Ernst Mach, who urged intellectual skepticism. There were few opportunities for him when he graduated. He took Swiss citizenship, but successfully appealed military service. He fell in love with Mileva Maric, another foreign student. They were married. Friends secured him positions teaching and in the patent office. In 1905, Einstein, at 26, had a family and had been a patent clerk for 3 years. He shared his thoughts with his friends, among them Michel Besso from the Zurich days, and a stylish bohemian society of 3 young intellectuals he gathered around him, the Olympian Academy, as they called it. The current state of physics was a favorite topic. In 1905, he wrote to one of his friends, "I'm sending you some revolutionary ideas." At the turn of the century, there were two alternative ways of viewing physics: through Newtonian mechanics or Maxwell's equations. 300 years before, Newton had described physical occurrences as instantaneous action between bodies at a distance. This worked well with the motion of planets around the sun, as well as with motion on Earth, like the path of cannonballs. But there were other kinds of physical occurrences which Newtonian mechanics could not explain well: magnetism, electricity, and optics. Maxwell described these electromagnetic phenomena as moving like ripples on a pond, only faster at the speed of light. Interaction takes time. This scheme was embodied in Maxwell's equations. By 1900, there were two competing research efforts to reduce the world to one or the other system. Maxwell's view was particularly successful. People thought that was the right direction. But Einstein had seen crises where others were confident. Historian of science, Arthur I. Miller.
Einstein viewed physics differently, in particular because of a thought experiment which he had conceived of in 1895. It concerned an observer on a cart moving along and who was capable of doing any sort of experiment, for example, measuring the velocity of light. The Maxwell theory predicted that the result for the velocity of light that the observer obtains should depend upon how fast the cart is moving. However, this was contradicted by certain experimental evidence. Einstein's intuition asserted that the result which the observer obtained should not at all depend upon how fast the cart is moving. Many physicists at the time proposed reasons for the lack of any effect of the cart on the measured velocity of light, which they tacked on to the Maxwell theory. Einstein, on the other hand, moved in a different direction. He cut through this situation by raising to a law of physics that the velocity of light is always the same and is independent of the motion of the source. This view is based on Einstein's other intuitive law, namely that the observer on a moving cart, where the cart is moving in a straight line at a constant velocity, this observer cannot do any experiment at all which will reveal the cart's motion. And this is what is known as the principle of special relativity. As a consequence of these two laws, time is no longer an absolute quantity, but rather it depends on the motion of the cart. This was a stunning result and ran against everyone's grain, including Einstein's. To convince himself of its veracity, he had to turn to the critical reasoning in various philosophical works of the time, which convinced him that the notion of absolute time was anchored in the unconscious. That is to say, the very high velocity of light, compared with all other velocities that we encounter in our daily life, has tricked us into concluding that time is an absolute quantity. Einstein's reasoning is something which transcended science as it is normally conceived. That is, it went from an analysis of science per se, to analysis of sensations, to an analysis of thinking itself.
Einstein soon realized his paper contained a thought which transcended relativity itself, the equivalence of mass and energy, the well-known E equals mc squared. Overall, Einstein's approach had been to accept principles justified by experience from Maxwell's and Newton's systems, but reject the idea that all of physics could be described by only one of them. With the speed of light established as a constant, Newton's mechanics was ruled out as the supreme system. Maxwell's systems were adequately reinterpreted, but this revision only lasted a few years. The German physicist Max Planck had discovered that some types of light radiation did not correspond to Maxwell's wave scheme, and Einstein himself demonstrated that it was useful to think of light not as waves, but as discrete particles, quanta. He remained a patent clerk for 4 more years. Then finally came recognition and employment as an academic. In 1911, he was invited to a major conference for his work on light quanta. The Solvay Conference was an expression of the era of international science. Madame Curie, radioactivity. Poincaré, who nearly expressed relativity. Lorentz, the electron. Rutherford, the atom. But it was the young who were creating the theoretical framework, especially Einstein and the Dane Niels Bohr, who was formulating a new model of the atom. Einstein now had obtained some security, a chair in physics at the German University in Prague. The university is near the old Jewish cemetery. Here, the images of Jewry were strong. It was a reminder of the role of the Jew in European civilization. Civil servants were required to have a religion. Einstein wrote on the state questionnaire, Mosaic. Prague was a time of crisis for him. Marriage with Mileva was failing. The author Kafka described this declining world: militarism, authoritarian bureaucracy, a monarchy unable to rule 18 different nationalities. Anti-Semitism flourished. A friend introduced Einstein to the intellectuals around Kafka, critical of the morality of European civilization, concerned for the fate of Jewry. There is unfortunately no account of the meeting of Kafka and Einstein. In Prague, Einstein's political sense began to develop. His political philosophy came from the same source as his science. As a youth, he understood that the validity of a human or natural system is dependent on the logic of the rules governing the system. At 12, in a moment of intuition, the principles of Euclidean geometry were self-evident to him. But principles, both moral and scientific, had correctness only insofar as they were justified in everyday experience. These ideas were soon to be tested in the center of civilization. He had left Prague in 1912, returned to Zurich. Then came Berlin. The proudest tower in Europe was Berlin. Its monuments were testaments to its victories. Its streets the triumphs of 19th century civilization. No other nation had so well ordered its social energies and ideas. As an expression of this national power, Kaiser Wilhelm II had created an Institute of Physics which was independent of the university. Einstein was brought in as its director, as a celebrity. He joined the elite of European physicists. They were conservators of a system of science which had grown with and supported the development of the German nation. Out of the laboratories and the seminars of the universities came the ideas for petrochemicals, electricity, military technology, which had created the industrial and military power of Germany. Explosion in knowledge was in turn protected by the military. This was Kultur, the proportion of ideas and power. 5 months after Einstein came to Berlin, the war happened. 93 German intellectuals immediately delivered a manifesto to the world. They urged faith in German militarism as the protector of civilization, and of the German nation that holds the legacy of Goethe, Beethoven, and Kant no less than hearth and home. Another manifesto followed, signed by 4 academics. Einstein shared in the writing of this document. Suddenly, instinctively, Einstein emerged as a pacifist on the European scene. Never before has any war so completely disrupted cultural cooperation. Technology and communication suggest the need for international relations, which will move steadily toward a universal civilization. The scientist Georg Nicolai, who organized the manifesto, was not a Swiss citizen like Einstein. He went to jail. During the war, Einstein remained in touch with European intellectuals, among them Romain Rolland, on the subject of peace. German scientists, to Einstein's dismay, put their knowledge to work. It was the same everywhere in Europe. His friend Fritz Haber developed nitrates for gunpowder. Walter Nernst helped develop mustard gas. Trappings of war became everyday surroundings. More heroes, more soldiers on the street. Einstein faded into the German home front. There was a second marriage. Through relatives, he had met his cousin Elsa, a good-natured woman. She looked out for him. He settled into the routine of a Berlin teacher, pursued his science. The war ended in 1918 with an outburst of revolution. The world around Einstein changed abruptly. A democratic republic was proclaimed by the socialists, the Weimar Republic. Einstein took on a new role, not unanticipated, representing the university during the revolutionary days. And when the victors blockaded Germany, he sought to plead with them on behalf of the famished population. But the Germans were the outcasts of Europe. At Versailles, the leaders of the Republic acknowledged war guilt, but were forced to accept a treaty with reparations. As this post-war political order was created, Einstein's new concept of the universe was being tested. During the war, he had completed major works. Some of his work in atomic physics ultimately resulted in laser technology. The primary achievement was the completion of the laws of general relativity. They would become the foundations for understanding a universe later to reveal itself. Black holes, gravity waves, and expanding boundaries.
Even though special relativity removed the absolutism of space and time, it referred only to reference systems moving in a straight line with a constant velocity. Einstein removed this restriction by means of another thought experiment. Newton's mechanics predicted the same results for the case in which the cart is uniformly accelerating in a straight line, or when the cart is at rest but is in a constant gravitational field. Einstein concluded that we have no reason at all to distinguish between those two cases. For example, if you're in an elevator accelerating upwards, your briefcase feels heavier. But you could also consider yourself to be at rest, but in a gravitational field which is more intense than the one you would be in if you were standing on the Earth. So Einstein concluded one cannot do any experiment, whether it be electrical, optical, or mechanical, which can distinguish between the cases in which you're in a system which is accelerating or in a gravitational field. This is the principle of general relativity. Application of this principle to the Maxwell equations led Einstein to conclude that the velocity of light is a variable quantity, that is to say, it depends upon the gravitational field, and light can take a curved trajectory in a gravitational field. Another consequence was that measuring rods could be so severely distorted in gravitational fields that the concept of distance is very difficult to define. What Einstein ended up with was a mathematical formulation of curved space-time, in which the curvature of space is determined by gravitational field. Since fields result from matter, therefore it is matter that causes the curvature of space.
General relativity predicted the curvature of light near massive bodies. An English expedition organized by Eddington in 1919 and a later American expedition tested this prediction during the eclipses. Had Einstein been wrong, there would have been no bending of the starlight. The observed deflection was within acceptable limits of prediction. The event made news, and the myth quickly emerged. Einstein was now a world celebrity. To the popular mind of the Jazz Age, he was the founder of a modern way of thinking. It's all relative. The familiar images of the world traveler began to take shape. His lecture tours abroad are fetes and ballyhoo, none more so than his first trip to America. But there are serious purposes. The American trip was funded by the Zionists to raise money for the Hebrew University in Palestine. It was an emotional occasion when he inaugurated the university the following year. He speaks of educational opportunities for all Jews and of cooperation between peoples. On the international scene, he worked with scientists such as Madame Curie and a League of Nations committee to restore the international communication of science and ideas. But order in post-war Europe was built on weak foundations. The League committee was hindered by French and German antagonism. In Germany, there were threats to the socialist Weimar Republic. In 1920, a putsch was organized in Berlin by intellectuals and soldiers dissatisfied with Versailles. Much of the violence was near Einstein's house. The right was emerging in the post-war world. Even though the putsch failed, the coalition extended into the academic world. Groups associated with it singled out Einstein and relativity for attack. Among the leaders was Philippe Lenard, a Nobel Prize winner. The anti-relativity group organized a public meeting. Einstein was present to hear relativity denounced as Jewish and hostile to the German spirit. In the nationalist revival, anti-Semitism was a force. Einstein is a rebel, internationalist, Jew. Lenard was extreme among academics, but there had already been in the academic world a sense of opposition to the Republic. Many felt themselves the embodiment of the traditional culture. There were still old friends, Planck, van Lau, Haber. But Einstein is the outsider. The Gumbel affair focused his alienation. Emil Gumbel, a young scientist, was denied promotion because he exposed assassination attempts on Weimar officials. When Gumbel sued, Einstein supported his civil liberties. For this, he was censured by his colleagues. There was a crisis in democracy in Weimar. Einstein was identified with its preservation. His political beliefs, like those of this socialist election film, envisioned the state as a rational social order, ensuring an education based on reason, planning technology, providing employment and material security. The goal of the state was the development of personality. The Einstein Observatory at Potsdam expressed this ideal: experiment, but order, reason, the humanity of technology. In contrast to the monuments of nearby Berlin, it was designed to reflect the rhythms of Einstein's universe. Simplicity was the way of the man himself at Kaput, his house in the lake area outside Berlin. He was followed here by politicians and academics, like the American physicist who took these home movies. But here he could sail, think, lounge with friends. The informality became part of the legend. By 1929, Einstein was acknowledged as the high priest of science. He had a Nobel Prize for physics. He was the embodiment of European civilization. 5 years before, the Sorbonne had snubbed him as representative of German culture. Now, it accorded him its highest honors. At 50, Einstein was at the peak of the scientific community. His work was the starting point for a golden age of physics. There was a new generation of scientists. To these young lions, physics had its limits. Heisenberg expressed the sense of things. One could not find the location of any one subatomic particle because any measurement, necessarily with light, affected the result. Einstein's old friend Niels Bohr gathered the youth around him. "We cannot know reality for certain," he said, "only that it behaves as both particles and waves." This ran against Einstein's instinct for order. The exchanges between them were intimate and intense. Einstein argued that God would not play dice with the universe. There must be order. Bohr, that uncertainty was itself a principle of the universe. Einstein presented thought experiments in which the position of atomic particles could be determined. Bohr countered that these conflicted with the evidence of Einstein's own general relativity. Einstein could not shake the belief of international science in uncertainty. In another world, in Berlin, Einstein was often in a cosmopolitan society of writers, artists, academics. Supporters of Weimar democracy, they shared also Einstein's internationalist and pacifist views. Einstein was among their leading advocates. Geneva, the League of Nations, was the center of this society. A European outlook flourished around League programs for disarmament, extending from the far left in France to the heart of the English establishment. These are the voices of militant pacifism, reason, here gathered with George Bernard Shaw at a banquet honoring Einstein.
Napoleon and other great men of his type, they were makers of empire. But there is an order of men who get beyond that. They are not makers of empire, but they are makers of universe. Their hands are unstained by the blood of any human being on earth. Ptolemy made a universe which lasted 1,400 years. Newton also made a universe which has lasted 300 years. Einstein has made a universe, and I can't tell you how long that will last.
In Germany, the Weimar government was disintegrating. The Depression was beginning, and the issues of democracy were being taken to the street. Those who spoke of reason and brotherhood were few in number. Einstein at a 1930 radio exposition.
Wenn ihr den Rundfunk höret, so denkt auch daran,
the real source of all technical progress is divine inquisitiveness. And the instinct for play, the constructing and pondering researcher. And, no less, the constructive imagination of the technical inventor. The technicians not only ease the daily work of humans, but also make available the works of the finest thinkers and artists to the general public, whose enjoyment only a short time ago was a privilege of the great, and thus awaken the peoples from a sleepy stupor. That same year in 1930, Einstein made the first of 3 annual visits to America. His humanity was quickly projected to the public in newsreels such as this.
In the greatest city of the world. I'm delighted. I'm delighted. What do you think of prohibition, Professor? Ich trinke nicht, also ist mir das ganz gleich. He doesn't drink at all, so he is not interested in this question. Professor, freut es Sie hier in Amerika wieder zu sein? Wenn ich nicht sehe, sicher.
His welcome was the kind given to the heroes of the age. He looked like Chaplin, and he had brains.
What did you think of the reception of the post, the children?
Ja, das war reizend.
Nice?
Yes, das war
Like
wirklich
it?
reizend. He
They sung
was
beau-
touched to tears.
they
really,
sung beautifully, didn't they?
Yes, that was really nice. Love the children, and
Yeah.
so healthy, so healthy.
durch den überaus herzlichen Empfang, den Sie mir hier bereitet haben.
He was brought to the California Institute of Technology by the Chancellor, Robert Millikan, to work with Europeans and Americans on new theories of the expanding universe. Mount Wilson Observatory was the center of their work. When he arrived, American physics was at a turning point. American science had an inclination toward big equipment and experiment. Since 1900, agencies had been plowing millions into a dozen elite institutions. Now, out of this funding of best science, as it was called, Americans were emerging in the vanguard of world physics. The Nobel laureate Millikan himself, who had measured the charge of the electron. Harold Urey of Chicago, who discovered deuterium. The laureate Compton, who experimentally confirmed Einstein's light quanta. Lawrence of Berkeley, who was building the first of his big cyclotrons and represented the destiny of American science. For the first time, Americans could meet Europeans on their own ground. That Einstein, the leading physicist of Europe, undertook these visits was a recognition of this equality. there were other reasons. On the university scene, Einstein, adroit and charming, was a useful symbol for the promise of American physics. In California, it was a relaxed lifestyle. Einstein was at home in it, but irrepressible. He stood out among scientists with his independent views on man and society. He went his own way.